Hey everyone, another day, another LeetCode problem. So today we're going to be looking at maximum number of items from sale, part one, which was actually a question that was asked in today's weekly contest. So yeah, I'm just going to go ahead and explain this question rather than going through this problem statement. It's a little confusing. So let's look at it over here. Okay, so I'm restating what this problem actually is over here so we can understand it better. So they're telling us that we're given a number of items, and each item constitutes of a factor and a price. So what they're saying is when I buy an item, I get the purchased element, and I also get free copies of other elements whose factors are divisible by mine. So let's just look at that over here. All right, so this is an example of what items are. And by the definition, this first value over here is the factor, and the second value is the price. So they're saying that if I buy this item, 6,2, my factor is 6. So I will get this item and I'll get all other items whose factors can be divided by 6. In this case, there's nothing greater than 6. So yeah, and it shouldn't be the item itself. So let's look at this example over here. So 2. So if I buy this item, I get this item as well as this item because 6 can be divided by 2. So essentially, I'll be gaining 2 items from this purchase because I get free items for all the other items which have values that are divisible by this factor. Okay, so given that our goal is to maximize the total item copies obtained within a certain budget. So they're going to give us a budget that we can use to buy these items. All right, so an observation we want to make from this question is, since we're dealing with factors over here, so let's say that the factor is 1, then we know that this is our most valuable item because 1 divides all other factors. So if you are purchasing the item with a factor of 1, then you're getting all your other items for free. So let's take this example over here. If I was going to buy this first item over here because the factor is 1, as I can see, I know that everything else is divisible by 1 here. So I'd be getting this item and then I'd get this and this for free as well. So yeah, it's the item 0 itself as well as the free copies, which are from item 1 and item 2. So I'm getting 3 copies. And let's say I was going to buy item 2. So item 0, 1, 2 over here is a factor 7. Now, I see that there are no other factors which are divisible by 7. So I get item 2 alone, which is 1 copy. So this is less valuable. And in the case of 2 over here, again, I'd be getting only 1 copy because 2 doesn't divide anything else completely. All right, so let's define something as a gain before we get into how we're going to solve the problem so we can kind of have all our values and given data organized in a way that's usable later on to make things easier. So the gain is going to be the first, the copy we're purchasing itself, and then the number of free copies that this copy can generate. So let's take an example over here. So this, I've just written the factors because the price in this case doesn't, we're not considering it. So let's consider a factor of 1. So I see that 1, it's the copy itself as well as everything else that comes for free, which is all the stuff that are divisible by 1, which is 2, 3, and 4. So I get 3 values extra, 3 copies extra. So that's a total of 4 copies just by purchasing 1. Now, if I look at 2, see, I get 1, which is the item which had the factor value of 2 itself. And then I see that 2 can divide 4, right? So I get 1 additional copy, which makes it 2. Now, if I look at 3, I get the item with the value 3 itself, the factor value 3 itself. And nothing else is divisible, so just that. And it's the same case with 4 as well. I get the item alone. So that we'll pre-compute these values and consider it as a gain, which is basically the value that this item can contribute in terms of itself and all the free items which it can give us. So now the question becomes the cost of an item, we have the price, and we have the value of the item, which is the gain or all the copies that it can generate, and then we are given a budget. So given these values, we can either take or not take an item, but our eventual goal is that we want to maximize the item copies while still staying within our budget. So if you look at this, we have a certain number of items and we have the contribution of all those items. We can either take or not take these items, but eventually we want to maximize the number of total items that we're going to get. So if you look at that, that's a 0-1 knapsack problem with a bit of a twist where you have to use this gain and stuff rather than just the value it's contributing. So if you solved stuff like coin change or certain problems, then you will see that the logic here is going to repeat with a little bit of a twist. Okay, so our logic is each item can only contribute free copies once. So this is very important because that's given in our problem statement. So the first time I buy an item, I'll get all the free copies that are coming with it. But the next time I buy that item, I will only get that item. So after the first usage, all items just contribute one, which is themselves, and they don't give any other free copies. So it becomes within the budget B, let's buy items that give us the highest gain first. Okay, so let's consider each item and say, I'm either going to buy it or I'm not going to buy it. We're going to give like a priority to each item to see how much it's contributing. And we'll see how much like gain we get from that. And we're going to do that within our budget B. And after that, we might have like some remaining amount. So that remaining amount is obviously going to equate to items which are going to be reused, which are obviously going to only contribute one item. So later, with the remaining budget, let's go ahead and buy the cheapest item until we run out of cash. Because what's the use of buying a more expensive item if it's just going to contribute one? So we might as well buy a cheaper item. And if we had like a budget of 5 remaining and we had items of like price 1, we would rather buy 5 of those items than one item which was of price 2, right? Okay, I think let's go through an example to kind of understand this better. So this is given in the form of how the question is. We have items. So we have the factors over here. Factors are the first value, right? So let's go ahead and write that. We have factors, which are 1 and 2. And we have the prices, which is the second value over here. So we have price is 4 and 3. Now let's just write that here as well. So we have item 0 actually, item 0 and item 1. The factor of item 0 is 1. And for item 1, it's 2 over here. And the price is the 4 and the price is 3 over here. Okay, so let's look at 1. So 1, I can see that the second element over here, the second item over here has 2, and 2 is divisible by 1. So apart from just the contribution of this item, I also get the second item. So the gain from this is actually 2. But when I look at 2, I don't see any other elements which 2 can actually go and divide completely. So it's just going to contribute itself. So that's 1. All right, so in the case of 0-1 knapsack problem, we use a 2-dimensional DP. Obviously, this can be reduced to just a 1-dimensional DP, but for ease of explanation, I'm going to go ahead with the 2-dimensional one because that's more intuitive. So what is our DP going to represent? We're going to have a value I, and then we're going to have B. So it's essentially asking us the maximum copies obtainable using the first I items with a budget of B. Okay, so let's look at that over here, and we need a base case, right? So the base case here is that DP of 0 has all zeros, which basically says if I have a budget of like 0 to whatever my budget is, 7 in this case, and I'm purchasing no items, then my contribution of items is basically zero. I mean, that's such a given. So we're going to consider that as our base case over here. And our values of I will iterate from 0, 1, and 2, because our statement here, I starts from 0, and 0 is already filled. But those are the values of 0. We're going to start from the first one over here. So let's do that. And our B values will range from 0 to 7. Okay, so what happens when I am considering the first item, right? So I only want to purchase that item when I know that the price of that item is less than or equal to the budget B that I have, right? And this is actually for budget over here. It's not actually cost, it's budget. So let's say that I have a budget of 0, okay? And if I look over here, the cost of my first item itself, the price is 4. So for a budget of 0, I can't do anything. It remains 0. I go to 1, same case. I go to 2, same case. I go to 3, same case. But when I come to 4 over here, I see that the cost of this item is within the budget that I have, right? So what I want to go ahead and do is I want to take this item. So if I take this item will be contributing 1, right? And then I might have a remaining budget. So I want to look at budget minus whatever current cost that I took for that item, which is price of that item. And I want to see what was the gain that I got for that remaining amount when I had considered all the items before this, because as I mentioned, we're only considering each item once in our first pass, and then we'll take care of the remainders. So I want to go ahead and see if I take this item, what was the gain that I was getting when I was I'm taking this item and I have a remainder of this value. So budget minus cost of I. So if I go over here, I'm considering that I'm taking the first item, right? And the first item has a cost of, it has a cost of 4. And when I come to 4, 4 minus 4 is 0. So I'm gonna go ahead, and this will go to my base case. So I'll go to my previous row over here, and I'm gonna check what was the maximum gain that I had got from all the previous items for this remainder. Okay, so that's 0 over here. So it's going to be 1 plus 0. And as we were considering a take and a not take, so basically a take here would have just been the previous value over here. So then we are going to update this with the eventual maximum of either taking the element or not taking the element. So here it's contributing a value of sorry, I did make a mistake over here. So I don't want to do 1. So it's actually going to be the gain of the item itself. So what is that item contributing, right? So that item is contributing a gain of 2. So I want to go ahead and write 2 over here. Okay. Now let's look at another value over here. So even if I have a budget of 5 and I'm taking an item which is the first item and the price is 4, then I have a remainder of 1. And from the previous thing over here, I see that for remainder 1 there was nothing. So essentially everything is going to be filled with the value 2 over here. And then I'm going to go to my next item. So I have finished this first item, and I'm going to go to the next item, which has a factor of 2 and a gain of 1. All right. So the price of the second item is 3, right? So the price is 3, and I know till my budget allowance is 3, nothing can really happen. So nothing happens here. But when I come to 3, I can see that, yes, I can do something over here, right? I can either not take it, so that not take value would have been 0, or I can either take it, which would be the gain that I'm getting from this. So the value that this item is contributing, which is 1, plus the gain that I was getting from the remainder after spending this much on this item. So that would have been 3 minus 3 is 0 from all the items before it. So the previous row and 0. Again, it's just 0. So I can go ahead and update this value, and it's just going to become 1. Okay, so for now, this value over here, again, 4 minus a cost of 3 would have been 1. But 1 over here is like we see it's 0. So we can either not take it. By not taking this this item, it would just remain as the value before it. So that's what's going to happen over here. It's going to be 2. Even in this case, it'll be 2, it'll be 2, because our remainders were things that are obviously zeros over here. So instead of taking this item and having a remainder that's giving us no gains, which wasn't possible at all, it's better to just not take this item. And then when we come to the last situation over here, where our budget is actually 7, okay? So I have a budget of 7, and my item cost over here was 3, right? So I do 7 minus 3 is equal to 4, okay? So 7 minus 3, my item, like if I don't take it, so let me just rub these things off. Our not take situation here would have just been the value before it, which would have been 2, but our take situation would be the gain that this is giving plus whatever gain the remainder from items before previous items, okay? Okay, what that's giving. So a 1 gain from itself plus, so what was that? 7 minus 3 is equal to 4. Our remainder is 4. So if we had taken this item and we still had like a budget remaining cash of 4, and we know that we could have taken the previous element. So I'll go to the previous element and see that this is a value of 2, as in my gain from the remaining 4 coins or cash that I have would have been 2. So essentially, if I'm taking this item, I can get a gain of 3 because I'll be taking the item itself and the remainder for the item before this and the free item that was giving. So that would essentially have been 3, right? So at the end, we can go ahead and like check this array. In this case, fortunately, we have used all of our budget. It could have been the case that we had numbers that like the remainder wasn't actually divisible and we couldn't have finished that. So like, let's say we didn't have like a factor of 1, then we would obviously have to like, okay, if we didn't have anything which had a price that could have divided our actual remainder, so then in that case, because we're considering only one of each item, then we have the possibility that we wouldn't have ended up here, could have ended up anywhere over here. Okay, so in that situation where we would have ended up anywhere over there and we have considered all of our different items, we know that with the remainder that we have, we're going to go ahead and purchase the cheapest element until we reach our, either reach exactly for what our budget was or we reach very close to it. So, okay, I'm going to go ahead and explain the code. I think it'll be more intuitive. So like I mentioned, we're given items in the form of factors and their prices. And what we're going to do is, just for simplicity, we're going to separate that into 2 values over here, factors and prices. And then we want to calculate the gain for each item. Okay, so we have n items. And initially the gain is just 1 because it's the value, it's like its contribution itself. So we're going to loop through each item and we're going to loop through all the other items. And they've told us that the other items will only contribute if their factors are like, they can, they're divisible by that given other item that we purchased. And they shouldn't be the same item itself. So yeah, we have that over here. So if it's divisible, we're going to go ahead and increment our gain. And yeah, ours 0, 1 knapsack problem. So we're going to go ahead and take a DP. And it's a 2D DP. So we'll initialize budget plus 1 because we have to look for exactly budget. And we know it goes from 0 to the budget itself. So since we need that particular value, let's go ahead and take an extra value over here. And we want to do this in range n plus 1 because our previous row, as I mentioned, was for our initial zeros, which we're saying, I have all this budget, but I'm buying no items, which are contributing 0, our base case. All right, so we're going to start from the first row. We're going to start filling it up. We'll just take these values. The cost of that item is, because we're starting from 1, we have to do prices of I minus 1. And the value it's contributing is basically the corresponding gain. And the same way which we just worked out right now. So our budget will be starting. So it'll be starting from 0 up to our actual budget, which is given over here. Okay, so every time we do that, our not take option is checking what was the maximum gain for the same budget by using all of the items before this, considering all of the items before this. And then we have take a 0 because it could be the case that our budget is less than the cost of the item itself. So that's what we're checking here. And then, so if it is within the budget, then we're gonna go ahead and this is the contribution of this certain item, how much gain it's gonna give, like free copies in itself, everything. And then what was the maximum gain we were getting from the remainder, all right? So that's what we get from the row before this, like all the items before this, considering this was the remaining budget. All right, and for the maximum, we're gonna see, should I take this element or should I not take this element? Okay, by the end of this, like what we saw here, we're gonna have a filled DP. And now let's say that we had some kind of remaining amount after we had given equal consideration to all of these items for seeing how much gain they give. And as we were speaking about, like we should only consider each element once initially, because after that, we know that the gain value it's going to give will not be the same. Okay, so that's what we did here. We considered it once. And now, if we still have a remainder, what we're going to do is we're going to look for the cheapest element. Okay, so that's going to be the cheapest amongst all our prices here. And this, we'll consider our answer as 0. So what we're going to do is we want to go and check, because it could be that we don't really spend all 7. We might have some remainder here. So we want to go and check how much we've actually spent. So in our DP, we're going to go and see if our spend is equal to 0, then we're just going to continue. Or else we're going to keep on checking. So the remaining amount would be the actual budget, subtracting how much we have spent currently. So we'll go from something like this and we'll go checking the values. All of these are 0, so we don't want to consider those. We'll start considering from here and we'll go and check. So in my remaining budget, right? In my remaining budget, I know that whatever item I do purchase, which will be the cheapest item, is only going to give a contribution of 1, which is the item itself. So I might as well go with the cheapest item. So our total, which we can get, will be how much we get from that gain, plus the remainder divided by the price of the cheapest element, right? So eventually our answer will become a maximum of that. So we're going to go ahead and check here. And why we're actually doing this instead of just taking the last value is because there could be a situation where, let's say, taking all these coins could have given us some kind of gain, but actually we would have gotten a better gain if we were to just buy a single element of this and then multiple copies of like another repeated element. So that could also be the case. So that's why we are checking that. So let's just check the time complexity for this. So we are doing 2 loops over here. So this is O of n square. And yeah, so this is n again, and this is budget. So we have O of n square plus O of n into budget. So let's just kind of write that down. Time is O of n squared plus n into budget. Okay, so that's our time complexity and our space complexity. Okay, so yeah, these are just like n size, but when we go to our DP over here, this is n into budget. So we have n into budget. All right. So yeah, if you want to go ahead and further optimize this, actually you can reduce this two-dimensional DP to a one-dimensional DP. But you want to make sure, because since you're using a single DP, and you want to make sure that you're not reusing the same element. Like if I'm saying I'm buying this item and I'm getting this gain, I don't want to use the same element for the remainder itself, right? So we were checking the previous row. So make sure that if you're using a single dimensional DP for this, that you traverse backwards when you're doing the calculation for B. So that way you're not reusing the same populated values, because everything else that was populated in the DP would have been from the previous items calculation. So if you do it backward and you're using like allotted budget minus this cost, you'll be looking at the previous values and then you'll be populating this. So yeah, just make sure you do that. So if you do that, then yeah, you can reduce this from an into budget to just budget. So let me go ahead and kind of run this. Okay, we'll submit it. And yeah, it's a contest question, so it won't really give us much detail. But yeah, anyway, I hope you guys understood this. It really took me a while to wrap my head around it. So yeah, happy coding, everyone.